Good morning, everybody. I hope everybody woke up with this interesting presentation. And now, this is Serbian Open Exchange. My name is Goran Slavic. Most of you know me. And we are going to talk about implementation of MANRS in the IXP network of SOCs. What is MANRS? For those of you who don't know, MANRS is a mutually agreed norms for routing security, but it also has a nice acronym to have good manners in your network and to work with other networks. It's a set of directives and recommendations for network operators, and it consists of some concrete actions that operators should do with regarding to sort of four important points. That's filtering of your prefixes towards other networks in order to assure the correctness of the announcements that you are making to other networks. Anti-spoofing, that is to ensure that source addresses, that there is a source address validation of traffic that is exiting your network in order to make sure that you or some other customer of yours doesn't have some botnet that is spoofing its source addresses and by that means doing the DDoS attacks on somebody somewhere on the internet. It's a set of actions regarding coordination with other networks to ensure that your network has up-to-date contact information. So if there is some problem, some issue, there is an easy way to contact you and coordinate with you in order to solve that routing issue. And of course, the global validation. You need, according to these actions, to publish information of your network so that other operators, other networks can do a valid route information check and to validate your routing information on a global scale. Now, why is MANRS important for an IXP? First of all, it's a security issue. IXP is operating an infrastructure that represents an LTU network of high bandwidth capacity, and that is the fastest and for some the only way to do a local traffic exchange. It's a matter of quality because routing information distributed by IXP is the most important indicator of quality of the IXP itself. Regarding those two issues and a sort of a joint task is the reliability of the traffic coming from the IXP and reliability of routing information coming from the IXP so that customers have a sure way to reduce potential problems that may arise by those traffic and that information. And those three things generate a trust, which is most important, to ensure the quality of a relationship between IXP and its customers, but also the reliability of routing information carries with itself the relationship and quality of the relationship between the customers of the IXPs between themselves. SOC's implementation of MANRS, well, our idea, of course, was to improve the security of the SOC's network and its traffic. SOC's network is already located in several countries that force us to be vigilant about security and routing verification problems that may arise. Initial plan was to implement rigorous filters on all the peering sessions towards our customers. If some customers will have a problem, well, we will simply contact them and inform them and ask them to correct that. Unfortunately, we ran into a problem because even initial evaluation showed that there are more than 100 prefixes that are problematic regarding to root origin filtering and some other root origin verification. So actually what we did a router verification test We use some tools. BGPQD, it's a simple program. You can get it on GitHub that has the ability to generate for any type of equipment, Juniper, Cisco, for route servers like Quagga or for Bird, prefix and AS filters. We use Bird for our routing within the network on our software routers and on route server. And because it has ability to analyze the prefixes and not only to implement production filters, but also filters for some route analysis, we used Bird as a routing analysis tool. It was a simple procedure. We generated filters for each of directly connected SOX customers using BGPQD. We integrated those filters into the SOX route server and did a configuration of additional filters to those filters that we used for prefix announcement tool and from our customers. So those filters that were generated by BGPQD were actually not cutting off or filtering traffic, actual traffic of the internet exchange and actual prefixes of our customers. And then we analyzed the data that we got. Considering that we were not sure that at the first time that this procedure will work, we used the manual verification of all the routes and all the prefixes that came and were filtered. We verified the prefixes that did not pass those IRR filters, and then we decided what to do with those prefixes that didn't pass IRR generated filters. We modified some filters if in cases the prefix was wrongfully filtered. By wrongfully, I don't mean that the script made a mistake or the filter made a mistake. They should have been filtered, but we deduced that those prefixes were filtered because of some administrative mistakes. You will see what was the breakdown, why the prefixes were filtered. And we actually modified some production filters in cases where prefixes actually needed to be blocked because we had a sort of potential prefix hijacking, or we couldn't get an actual result. What was the problem? It was a very strange situation when we manually checked those prefixes against, for example, RIPE-DB. And we, of course, informed the customers of all the problems that we encountered so they could correct their announcements. What were the initial results? We analyzed little less than 18,000 prefixes, and the number of prefixes that were classified as problematic was little less than 460. We actually blocked or filtered in our production filters around 18 prefixes until we sorted out with our customers what was actually the problem and why those prefixes were badly announced. In the IPv6 sphere, we analyzed little less than 100 prefixes, and we came up with 5 prefixes that were sort of problematic, but none of the IPv6 prefixes needed to be completely filtered or blocked from announcement out of the route server because none of them were really generating a problem. There are 3 types of problems we detected, and there is a 4th one that potentially we could have detected, but we, heaven forbid, didn't arrive at any prefix hijacking, or we didn't detect it. First one was 2 specific prefix announcements, both on IPv4 and IPv6. Some prefixes, actually some ASs, didn't complete their AS set in the RIPE-DB for peerings that they had with other ASs. You will see the details later. And the 3rd type of problem was we didn't find no valid or usable or unique route entry in the RIPE-DB for some of the prefixes. Let's break out those problems. There was a 2 specific prefix announcement. In case of IPv6, that means that AS announced /24 prefix, but there was no route entry for that /24, but there was a route entry for /22, /18, /16. What's worse, out of those 460 prefixes, 412, that's a little close to 90% of the prefixes that we classified as problematic, did have this problem. In case of IPv6, AS announced that /48, but the route entry was for the original /44/32 that they got from RIPE, and that was the only route entry for that AS into the RIPE DB. And what's interesting, we didn't detect any other problems with IPv6, only the problem of two specific prefix announcements. Incomplete AS set the entry into the RIPE DB. If two ASs would peer, we call them AS1 and AS2, one of them, and in some cases even both of them, didn't provide a valid proper entry into their IS sets to regard that peering. So if you look at RIPE-DB, you wouldn't, there is no indication that those two ISs are actually peering. And if any IXP or even ISP that is doing the peering with one of those wouldn't know about the prefixes of the other AS, and if they would filter or generate some route maps filters using automatic scripting, these filters will drop those prefixes, for example, of AS2, because it doesn't know if those prefixes should be announced as from the network with AS1 as which is, for example, AS1 is the IXP customer, and you actually cut those prefixes of AS2 and ask the system administrator of AS1, why are you announcing AS2? We don't have any record that you should be announcing them. In 402 cases, or about 44%, prefixes was classified as problematic and had this problem. But what is rather strange, in 141 or 30%, they had both this and the foremost mentioned problem. Route origin problem. Well, in this case, search of RIPE-DB didn't produce a valid AS that should be the route origin of the prefix. 18%, a little less than 4% of prefixes were classified as problematic according to this criteria. In case of 11, other entries into the RIPE-DB enabled us to deduce what was the AS. So, for example, Lear simply didn't put the right data for its customer, which transferred the prefix to them. In 5 cases, we couldn't determine the entries into the RIPE-DB because, for example, one AS simply didn't put anything useful into the RIPE-DB. We couldn't deduce according to the RIPE-DB what was the problem there. And in 2 cases, our red flag got up because we saw the situation that could have probably been a prefix hijacking. But thankfully, in those 2 cases, this was not the instance of prefix hijacking. It was the result of missteps in prefix transfer between 2 ISs. Actually, when you manually check those prefixes, you will see that those prefixes actually had 2 route entries, from the old owner and from the new owner. And that sort of got mixed up, both the automatic script and actually set some red flags with us. Conclusion, MANRS implementation is a demanding activity, both from technical and from the business side. If you cut prefixes of your customers, you will actually drop the traffic on your ports, and that traffic will go somewhere else, and your business side is going to say, but could if we just let them through, it's their prefix, they just didn't sort of integrated it into RIPE-DB. But there needs to be a broader awareness of the problem that can arise as a consequence of bad routing information. There needs to be a better understanding of importance of up-to-date information in a relevant layer. As you can see, 90%, it was only a small misstep in configuring that /24 most specific routes in RIPE-DB, but that could have led to some serious problems because the legitimate owner didn't put up the right route entry, and that means that that route entry could have been misused by somebody else, and it would be very hard to prove in some situations who was the rightful owner. Thankfully, we didn't detect that, but it could have been a problem. And MANRS implementation needs to be a cooperative effort between IXP and its customers in order to be implemented without any bumps in the road. And for details, there is a contact, our contact, MANRS at SOX RS. So that would be it. Any questions?
Thank you. Goran, any questions? If you know, no questions here, then that's it for this session. It's time for coffee break, I hope. Then we will continue at 11.